Hey there, this is Mr. Wilford. I just wanted to go through Chapter 5, Section 3 with you real quick. Solving quadratic equations by graphing and factoring. And I'm going to talk about a few different things here and break this into two little videos for you, so there's kind of a lot to cover. First of all, when we talk about solving a quadratic equation, what we're talking about is finding a zero, or what we call the x-intercepts, where the graph crosses the x-axis, or in other words, sometimes we call them the roots. And basically what we're looking for are the x values that will make the quadratic equation equal to 0. So again, these are called zeros or x-intercepts or roots. And one way to do this, if you have a good graphing calculator, is simply just to plug in that quadratic equation into your graphing calculator and either look at the table or the graph to determine where that parabola crosses the x-axis. And if you look closely, you can actually tell that the graph crosses here at -3 and 1 on the x-axis. These would be the zeros of this quadratic function. Now, another way to talk about solving the quadratic equation, as I mentioned, we call them either zeros or roots. And to solve these algebraically, it kind of depends a little bit on what your quadratic equation looks like. So here I have an example, 2x squared equals 18. We could actually take this equation, this quadratic equation, and set it up as a difference of two squares. This is one kind of formula to help you solve quadratic equations. And this difference of two squares has to do with taking something like a squared minus b squared, where we're subtracting two perfect squares, and we factor that out into a plus b times a minus b. What I want to do is actually show you, I think, a different way, maybe an easier way to solve this kind of equation. And that involves taking this example, 2x squared equals 18, and this is an example, a quadratic, when you don't have an x term, you just have an x squared term. What I want to do is actually get that x squared term by itself, and the way that I'm going to do that in this example is divide both sides by 2. So the 2's cross out, and I get x squared is equal to 18 divided by 2 is 9. Now, I have the x squared by itself. What I want to do is get rid of the squared by taking the square root to both sides. When you do this, the square root knocks the squared out, and I get x equals. Now remember, whenever you take the square root to both sides, we have a plus side and a minus side to this, and then the square root of 9, of course, is 3. So we would end up with two roots here, two solutions. X equals plus 3, x equals minus 3. Okay, so that's one way to do that kind of problem. If we look at another kind of example here, another kind of quadratic, here I have a quadratic equation where I have an x squared term and an x term, and I can actually factor the greatest common factor out of each of those terms. So let me show you how that works. If you look at the first term, I have a 3x squared, and the second term is 12x. Well, 3 obviously goes into 3, and 3 also goes into 12. So I'm going to take a 3 out, and then I have 2 x's here and 1 x there. So I actually will take out a 3x, and what do I have left from each of these terms? Well, if I take a 3 out, that's gone. If I take one of the x's out, that's gone. So I'm left with an x. From the second term, if I take out a 12, 4 times 3 is 12, so I'm going to be left with a 4. The x is obviously gone. Now, how do you get your answers from this? Well, whenever you have an x by itself, there's 3x. It doesn't matter the number, it's just the x that we're looking at. One of my roots will always be 0. So that's one of my answers. When you have a factor that looks like this, what you're going to do is actually take the opposite of this number. So here I have a plus 4, so one of my roots will be a -4, the opposite of that. So this would be my answer. So this is the first part.